epicyclic gear train, right? So in order to find this velocity ratio, usually in epicyclic gear trains, we will use two methods, right? One is called as tabular method and the other one is called as algebraic method. The following two methods may be used for finding out the velocity ratio of an epicyclic gear train, right? So tabular method and algebraic method can be used to find the velocity ratio of an epicyclic gear train. We'll see one by one. Right? So first one is the tabular method. So this is a normal picture, right? So based on this, we are going to do how we are going to analyze how to do that. Say for example, TA is a number of teeth on gear A, right? So gear A has TA number of teeth. TB number of teeth on gear B, right? TB, that is number of teeth on gear B. Suppose that the arm is fixed. So here we will assume the arm C is fixed, right? So arm can't move now. So this is fixed. Therefore, the axis of both the gears are also fixed relative to each other. So if the arm can't move, if this one can't move, what will happen? This A and B need to rotate only on this axis, right? This is not going to move, right? So if A is rotating this way, right? If A is rotating this way, B needs to rotate this way, right? And vice versa. So this is more like a kind of simple gear since the arm is not rotating. So we'll now see arm is fixed. Therefore, the axis of both the gears are also fixed relative to each other. So this axis is fixed, this axis is fixed. So now this is going to rotate based on this axis, and this is going to rotate on this axis. When the gear A makes one revolution anti-clockwise, when the gear A makes one revolution anti-clockwise like this, right? One revolution, the gear B will make TA by TA revolution clockwise. So we'll see how is that. So if this rotates at anti-clockwise, this will rotate in the clockwise. That's definitely everyone know, right? And we know speed ratio is NB by NA is equal to TA by TB, right? So speed ratio will be given by inverse of number of teeth, as you know. So NB upon NA, that is speed of NB upon speed of A equal to TA upon TB, right? So 2 teeth at A upon teeth at B. Here number of speed at B and speed of A. Here given is when the gear A makes one revolution, right? So instead of NA, I'm going to put now 1, right? Why? That's how it's given, right? So if the gear A makes one revolution, so now my equation is going to be NB upon 1 is equal to TA upon TB. Okay, NB upon 1 is equal to TA upon TB. So that is equal to NB is equal to TA upon TB. Since NA is equal to 1, right? Right? This is 1. So NB is equal to TA upon TB, right? So speed of gear B is equal to TA upon TB. So that's what mentioned by when the gear A makes one revolution anti-clockwise, the gear B will make TA by TB revolution clockwise, right? TA by TB revolution clockwise. Okay, so that's this revolution TA by TB revolution clockwise. Assuming the anti-clockwise rotation as positive and clockwise as negative. So when we put in the tabular method, if we consider clockwise motion as positive, then we should consider anti-clockwise motion as negative. Or if you consider clockwise as negative, then you should consider anti-clockwise as positive. This is a must rule in the tabular method, right? So that's what making here. Assuming the anti-clockwise rotation as positive. So if you assume anti-clockwise rotation this as positive, then you should consider the clockwise motion as negative, right? So this is a must rule, right, in tabular method. All right. Now we'll see how to put this data into the table, right? So this part is clear, right? If this is making an clockwise rotation, this will definitely make an anti-clockwise rotation. First thing, if the NB upon NA is equal to TA upon TB, And if NA is making only one revolution, then you will have NB is equal to TA upon TB, right? Now we'll see how to put them in the equation, right? So this is a table. Conditions of motion. We'll specify the conditions and then we'll put it in the table. Arm fixed, gear A rotates through +1 revolution. Okay, arm is fixed, so the condition is arm is fixed, right? So no movement for arm. Gear A rotates through 1 revolution, that is 1 revolution anti-clockwise. So it is given 1 revolution anti-clockwise. So gear A is making a 1 revolution anti-clockwise. So now it is obvious gear B is going to make a clockwise revolution. So if A is making 1 revolution anti-clockwise, right, then B will have TA by TB revolution clockwise, right? That's what we have seen in the last slide, right? So if A is making 1 revolution anti-clockwise, okay, then A is making, sorry, B is making TA by TB revolution in the clockwise, right? So you see here, okay, if A is making 1 revolution anti-clockwise, B is making clockwise TA by TB, right? So since clockwise is considered as positive, I will put anti-clockwise as negative, right? This is again a must rule. So if clockwise is considered as positive, then anti-clockwise is considered as negative, right? Or you can consider other way also. You can consider clockwise as negative and anti-clockwise as positive. That's your idea. But if one is positive, the other one is negative, right? So based on our equation, I will have NA upon NB is equal to TB upon TA. And again, if the NA is equal to 1, right? Fixed gear OA rotates at 1 revolution. So this is now going to be equal to 1. So 1 upon NB is equal to TB upon TA. NB is equal to TA upon TB, right? NB is equal to TA upon TB. So when NA makes 1 revolution, NB is making TB upon, sorry, TA upon TB, right? TA upon TB. So what will happen if A is making a X revolution? Okay. So arm fixed A rotates through 1 revolution, B is at TA upon TB, anti-clockwise, so there's a minus. That's here. Okay. Arm fixed gear A rotates through plus X revolution. Here that was 1 revolution. Now it is X revolution. So what we will do, we will simply multiply these entire values by X, right? So here I have 0. 0 multiplied by plus X. We will not have anything against 0. Here plus 1, right? This is plus 1 revolution. But here that is X. So I will multiply it by X. So plus 1 into plus X, that is plus X. For 1 revolution, I have TA upon TB revolutions, that is for gear B. So I will now multiply this one with X. So I will have minus into X into TA by TB, right? So here, this is for 1 revolution condition, this is for X revolution condition. Now, this arm, assume, is going to move, right? So here we stop the arm and put the values for A, right? Now arm is also going to move. Add plus Y revolutions to all elements. Why? Because arm is going to move mean this arm is going to move, this B is going to move, A is also going to move, right? So I will add plus Y for all elements. So I will add plus Y here, plus Y here, plus Y here. This plus Y is the movement of the arm, right? So total motion. So here, if you carefully observe, arm fixed gear A, right? So here, arm is fixed, gear A and gear B are moving, right? Here, arm is also moving. So already gear A and gear B are moving. We stop the arm. Now, on this row, arm is also moving, which means A is moving, B is moving, arm is also moving. All right. So now everything is moving. So I will add plus y to all three columns. At the end, we are going to have the total of this. So here, if you see y plus 0, that is plus y. Okay. Here, when arm was not rotating, only A was rotating, that is x rotation. Now arm is also rotating, that is y rotation. So here we will add x plus y, right? X is the movement of A and y is the movement of arm, totally x plus y. On this gear B, if the arm is not rotating and if the gear is only rotating, I had x into TA by TB minus, because this is the opposite direction, right? So this is without arm moving. Here when you add this one, now arm is also moving, B is also moving, right? So we will add these two, plus y, right? Plus y minus x into TA by TB minus x into TA by TB, right? So the total motion, the motion of B is given by y, that is moment of arm, minus x into TA by TB, right? So this x is the rotation of A into TA by TB, that is speed ratio. All right. This is what called as the tabular method. Any doubt in this? So here you need to visualize how A is moving, how B is moving, how the arm is moving. You need to imagine. So this is a kind of relative motion. So we are stopping one by one, and at the end we are adding everything. So here at the start we stop this C in order to fix this A and B's movement. So when we find the A and B's movement, I have C and adding the movement of C also, right? So now everything is moving. So this is a kind of relative motion, right? An epicyclic gear train, an arm carries two gears A and B, right? So epicyclic gear train arm carries two gears A and B, having 36 and 45 teeth respectively. So A has 36 and B has 45 teeth respectively. If the arm rotates at 150 rpm, so if the arm rotates at 150 rpm in the anti-clockwise direction, so this is going to move this way about the center of the gear A, which is fixed. So now the gear A is fixed. Okay. Determine the speed of gear B. So under these conditions, you need to find the speed of the gear B. If the gear A, instead of being fixed, makes 300 rpm in the clockwise direction, what will be the speed of gear B? So there are two questions actually. One, if the A is fixed, what would be the velocity of B? I mean speed of B. Second question, if the A is also rotating with 300 rpm in the clockwise direction, what will be the velocity of B? Right. So now we'll fix the given data. Right. TA, that is 36. So number of teeth on A is 36. TB is 45. Number of teeth on gear B is 45. NC is 150 rpm. So rotation of link C is 150 rpm, and that is anti-clockwise. So now this link is going to rotate like this. Okay, and this is fixed. A is fixed, so NA is going to be fixed. Question asked is, when this is fixed, what would be the speed of B? Second question, when this is moving with 300 rpm in the anti-clockwise direction, what would be the speed of B, right? So this is a question. We'll now see how to solve this. So first we'll solve with the tabular method, and then we will solve in the algebraic method. Okay, we'll solve by both the methods. First of all, prepare the table, right? So we know, according to given condition, arm fixed, gear A rotates through +1 revolution, right? If, right, so these are if conditions. So arm is fixed means 0, but in our case arm is not fixed. Okay, gear A making 1 rotation, so 1. Gear B, we know if gear A is making 1 rotation, gear B will be making anti-clockwise direction, that is minus TA by TB rotations, right? arm fixed, gear A rotates through X revolution. So if it is 1 revolution, B is making minus TA by TB. If it is X revolutions, I will multiply this with X. So that is minus X into TA by TB, right? Arm again, if I multiply by X also, that is 0. 0 multiplied by X, that is 0. Add positive Y revolutions to all elements. So this positive Y is the movement of the arm, right? So if the arm makes positive Y, so I will add positive Y to all three elements, arm C, gear A, and gear B. So total motion is, I will add everything. So plus Y for arm, gear A, that is making X motion, arm is making Y motion, so X plus Y. For gear B, arm is making plus Y motion, gear B is making minus X into TA by TB motion, so the total motion will be Y minus X into TA by TB, right? Now we have the table, we will substitute the numbers, right? Speed of gear B when A is fixed, right? So when gear A is fixed, right? Since the speed of arm is 150 RPM anti-clockwise, therefore from fourth row of the table, right? So from this row, which is mentioned, X is making X revolution, Y is making Y revolution. Total motion is X plus Y for gear A, right? So here, last row of the table, Y is equal to plus 150 RPM, right? Y is equal to plus 150 RPM. Y arm C is making 150 RPM. That is given, right? This is a motion of arm C, and arm C is making 150 RPM. So that is this Y is equal to 150 RPM. Also, the gear A is fixed. Therefore, so here if you see, this is for the gear A. So gear A making one rotation, gear A making X rotation. This is for arm C, and this is total motion of gear A. But gear A is fixed, so which is not moving at all, which does not have any movement. So X plus Y is equal to 0, right? Why? The gear A, the motion is X plus Y, right? So X plus Y is the motion of gear A, but it is 0. It is not making any movement, right? So X plus Y is equal to 0. All right. So here I have X plus Y is equal to 0. So from this, X is equal to minus Y. You see from here, X is equal to minus Y. Y I know already, that is 150. So if I substitute this 150 over here, I will have X is equal to minus Y, which is equal to minus 150. So X is equal to minus Y, that is Y is equal to 150. So minus Y is minus 150 RPM. Okay. So X is equal to minus Y, which is equal to minus 150 RPM. And therefore, speed of gear B. So now we'll go here, speed of gear B. So this is gear B, right? So speed of gear B, Y minus X into TA by TB. Now we know Y, that is minus 150. Sorry, 150. And we know X, that is minus 150. TA given in the question, TB given in the question. We will replace everything. All right. So NB is equal to Y minus X into TA by TB. Okay. The Y, it's given 150. That is movement of the arm. Plus Y plus here. Here I have X is equal to minus 150. Equation there is another minus. So minus into minus plus. Right. That plus X I replace by 150 into TA by TB. Number of teeth on A and number of teeth on B, that is given 36 by 45. So when I solve it, I will have 150 plus 150 into 36 by 45. So if I solve it by 9, I will have like 4 by 5. So 5 and 150 will cut by 30 into 4, 120. 150 plus 120, 270 RPM, right? So when the B is, A is fixed, the motion or speed of B is 270 RPM anti-clockwise, right? 270 RPM anti-clockwise. So when you solve it, you can have in the equation, so what is the RPM coming as, right? So since the speed of arm is taken as anti-clockwise, right? So this is also already given in the question, and you are replacing everything according to the equation. So whatever the plus or minus coming here will give you the direction. If 150 is anti-clockwise and that is positive, 270 anti-clockwise, that is also positive, right? If it is 270 and clockwise, then this answer will come in minus, right? So if you are doing correctly, replacing everything based on anti-clockwise, clockwise, taking positive and negative appropriately, you will have proper answer, right? Right. The next step on this, speed of B when gear A makes 300 RPM clockwise, right? So in the previous question, A is making not any movement, that's idle. So here we'll see arm fixed and gear A rotates through a positive X revolution. So instead of this X, I will replace it by 300. Why? Because A is making a 300 RPM clockwise, right? Since the gear A makes 300 RPM clockwise, therefore, from the fourth row of the table, X plus Y is equal to minus 300, right? 300 RPM clockwise, okay? And we took anti-clockwise as the positive, right? So now it is given clockwise. So clockwise means we have to put negative. And this is a motion of A, right? This is a motion of A. So motion of A, it is said that, right? Gear A makes 300 RPM clockwise, right? So X plus Y is equal to minus 300, right? X plus Y is equal to minus 300. Minus is for clockwise motion because anti-clockwise is taken in positive here, right? You see here, anti-clockwise is taken as the positive. So clockwise means definitely you have to put the negative. And 300 is the motion of the A, right? From here, I can find X is equal to minus 300 minus Y, right? X is equal to minus 300 minus Y. So minus 300 minus Y, that is equal to minus 300. Y we know that is 150. So minus 300 minus 150, that is equal to minus 450 RPM. Okay. So now we can replace it with this equation. I know Y, I know X, T and T, TA and TB are given. So I will go for this. Okay. So NB, that is number speed of B is equal to Y minus X into TA by TB. Y, that is 150 RPM, right? 150 minus into X. So X is, you see, minus 450 into there is another minus. So that minus plus this minus equal to plus 450 into 36 by 45. So this 36 and this 45 are given in the numerical, right? 36 teeth for A and 45 teeth for B. When you solve this, I can solve it by like normal equation. So when you solve it by 9, I will have 4 here. Then I will have 5 here. 5 and 450, that will be like 90. 90 into 4, 360. So 360 plus 150, that is 510 RPM, right? So when now you got the answer into plus, that is 510 RPM. So plus mean anti-clockwise, right? According to what you have taken, plus you have taken as anti-clockwise. So you got your answer in plus, which means your B is rotating at anti-clockwise direction. So B is making a motion of 510 RPM in the anti-clockwise direction, right? So this is usually how we do the tabular method, right?